start looking at partial fraction decomposition. There's a couple of different forms of this, so if you're coming to this revision and you've seen this before, we're just going to look at the simplest form in this video and then the techniques for actually solving these equations, which will apply to all the forms. But then in the next video we're just going to basically list off all the different forms you need to remember to set up these equations. So whichever form we're dealing with at this level, our numerator is always going to be linear or constant, so it takes the form x plus b. And in today's video we're going to look at when we have a quadratic on the bottom that can be split into two linear factors. So cx plus d and then ex plus f, and what we're aiming to do is separate this fraction out. So this is clearly the sum of two algebraic fractions. Okay, so we know when we add algebraic fractions we have to find the common denominator and then add up the numerators. Okay, so the technique we tend to use is cross multiplying, which does this, and what we're trying to do now is the reverse process. So starting with an already simplified fraction, we're trying to separate it out into a sum of other algebraic fractions. So what we can say is, for all x, okay, so this is why we use an identity sign, there is a and b which satisfies this equation. And the reason this works is if we were going to add these up and cross multiply, we'd get a multiplied by ex plus f plus b multiplied by cx plus d over cx plus d times ex plus f. But then, so to find our a and b, we have to solve for a multiplied by ex plus f plus b multiplied by cx plus d is equal to ax plus b. Bear in mind all these lowercase letters in examples will be given. There'll be numbers. We're just trying to find capital A and capital B. So I'm going to multiply up both sides with this so you can actually see what I'm saying. So we get ax plus b is equal to a ex plus f plus b cx plus d. Now we can do a trick called, there's two ways we can solve this. Because it's an identity, this is true for all x. So we can either pick values of x that make one of these brackets 0, and then that will eliminate a or b depending on how we choose x, and we can solve for the one that's non-zero, and then we can pick another x which makes the other value 0 and then solve for the other value, and then we've got two values. Okay, then we found a and b. Or, and my preferred method, but both are perfectly fine, is equating coefficients. So we know that the x coefficients have to be equal and the constant coefficients have to be equal, so we have little a is equal to ae, because we get aex here, plus bc, because we get bcx here, and we also know for the constant little b is equal to a multiplied by f plus b times d. Now we have a pair of simultaneous equations which we can solve. Okay, so let's look at an example. If we have 3x over x minus 1 multiplied by x plus 2, and we want to rewrite this in the form a over x minus 1 plus b of x plus 2, and this takes me back to what I said at the start. We're looking at the different forms. If we have something different on the denominator here, or something different, then we have to try and fit it into a slightly different form here, because it won't fit into this form there. But we'll look at that, as I say, in a later video. So now we multiply it by these, we get 3x is equal to a times x minus 2 plus b x plus 2 b x minus 1. So now we know 3 is equal to a plus b, and we also know that 0 is equal to 2a minus b, and that very quickly implies that b is equal to 2a, and we can substitute that into 1. So substituting equation 2 into equation 1 gives us that 3 is equal to a plus b, which is 2a, so plus 2a is equal to 3a, which implies a is equal to 1, which then implies b is equal to 2. So we have our answer, 3x over x minus 1 x plus 2 is equal to 1 over 1 x minus 1 plus 2 over x plus 2. We can check this, cross multiply it. So we do x plus 2 plus x plus 2x minus 2. So the 2's cancel each other out, we just get 3x on the top, and we multiply it. There you go, brilliant. Okay, so that's our answer. That's all we're going to do in this video. In the next video, as I said, we're going to look at the different compositions you can get, and we'll perhaps maybe solve it using the method of choosing particular x's, so you can see that one. But as I say, that's it for this video. This is a new topic that we're looking on, but if you want to look at some of our old topics, we've got some videos on graph transformations recently and lots of other A-level maths topics. But for now, that's it, and I hope to see you in the next video.